Now we're going to look at problem number 8.28 for this example of constructing confidence interval for population proportion. Okay, we have a cell phone provider and it has a business objective of wanting to estimate the proportion of subscribers who would upgrade to a new cell phone. So they're going to introduce a new cell phone with improved features. Okay. Now, if they offer it at a substantially reduced cost, will there be enough people wanting to upgrade to this new phone? So data are collected from a random sample of 500 subscribers, and they were asked whether they would go for that deal, and the results indicated of that 500, 135 of the subscribers would upgrade to a new cell phone at the reduced cost. Now we want to construct a 99% confidence interval estimate for the population proportion of all subscribers. Not the sample is only 500. So for all subscribers, what is the true population proportion of subscribers who would be willing to upgrade? So let's start with defining terminologies. Okay, we always start with that. So first is we have to define what success in this binomial context is. So here subscriber would upgrade to the new cell phone. So that is success. So then pi is the proportion of all the subscribers who would upgrade to the new cell phone with the new features. Okay, so that is the context. Now we start with n. N is the sample size here, and sample size is 500. We're taking 500 subscribers. Of that 500, the number of successes is 135, and it's given. So we're just entering the numbers. These are given in the problem. So here the lowercase p is the sample proportion. So we define that proportion of subscribers in the sample who would upgrade. So that we have to calculate. So that will be number of successes divided by the sample size. That will give us the proportion of subscribers in the sample who will be willing to upgrade. So now we compute the standard error of p, and the standard error of p is, so here in place of pi we have to put p in there. So that will be square root of, okay, so p times 1 minus p divided by the sample size n. So that will give us the standard error. Now we want 99% confidence interval. So let's put 99% there. So alpha is 1 minus that 99%. Now we want z sub alpha over 2. So the alpha over 2 now is what? 0.005. Okay, so it's 99% in the middle, 1% outside. So half a percent or 0.005 in the tail. So 0.995 for the cumulative probability. So let's go to the normal table. Cumulative probability of 0.995. So which is in the middle of these two. So there will be like 2.57 and 2.58. So the average of those two is 2.575. So we put 2.575. Okay. So that is 99%. Margin of error is z times s sub p. So now we can set up the lower and the upper limits. So we start with sample p minus margin of error, and then sample p plus margin of error. So in other words, we can say, well, before that, if you use the Excel function here, the Excel function will be norm.s.inv. We have to give the cumulative probability, not the tail probability. So we need to go 1 minus alpha over 2. Okay, and you see that this is actually 2.5 576, slightly different, but Excel function is more accurate, as I have said before. Z times S will give you the margin of error. So P bar minus margin of error, P bar plus margin of error, they all give us the interval. So another way, and then the interpretation is that we are 99% confident that the true proportion of subscribers who will be willing to upgrade is between 22 and 32%. So if you express this as percentages, 21.9 and 32.1%. We can also say this in the way the news reports say, which is that our estimate of proportion of subscribers who will upgrade is 27% within the margin of error of, so you express that margin of error is also as a percentage, and the margin of error is 5.1%.